Hello, this is a quick demo of the TripHut DAO off-chain library and how you can get started and use it to interact with the smart contracts on testnet. So to get started, I've just cloned the repository here and opened up the README file, right? And so the very first step here is basically to enter a Nix shell, and that's just going to set up our environment for us. So to do that, we would run nix develop. However, it does take a little bit of time initially to spin up everything. So I've already gone ahead and done that, and you can see here that I am inside the Nix shell. And from there, you can basically start, building or testing the library. But before we get doing that, I'll just show you a quick overview of the structure here. So inside of the source directory here, you'll see a number of subfolders. The most relevant one or most interesting would be the workflow folder. And this contains basically all of the logic for interacting with the smart contracts. So that's basically building transactions or querying the blockchain for certain information. Right? And so we won't get into the details of all these right here, but that's where you'll find them, all of the actual logic that's happening, not the on-chain logic, but the interaction with the on-chain. Um, so aside from that, if we look in the next directory here, we'll see it is labeled as web, and this is where the actual API resides. So basically the functions that you'd be calling from another code base, if you pull this into a TypeScript or JavaScript application, these are the actual functions you'll be interacting with. Now this is written in PureScript, so it looks a little bit unfamiliar if you haven't worked directly with PureScript, but essentially this will compile down in this library and be accessible in JavaScript, and we do have a separate file here that is the TypeScript definitions, right? So everything that gets compiled will ultimately be just regular JavaScript, and we've got the TypeScript file here to make life a little bit easier with all of the types defined. So circling back, going into the web directory here, so we've talked about the API itself that you'd be interacting with. Close out of. There's some other basically internal stuff here for wiring everything together, behind the scenes. Some conversion functions to go from JavaScript to PureScript, mostly just helpers, things like that. We've also got some utility functions. The next interesting folder here is the scripts directory, and this is where the on-chain logic that's in a separate repository, when that gets built, basically the output is serialized scripts, and they're saved into this JSON directory here. And so basically all of these are the actual scripts that are being run on chain. And so there's some other folders here, or files, I should say, where those serialized scripts just get copied over into PureScript. Um, it's actually under the serialized directory here. All right, so these are just the PureScript copies of the JSON files here, just for easily pulling them into the relevant PureScript files. But we don't need to interact with these directly, so I'm just going to go ahead and close out of that. And then finally here we have components, and this is just, again, some more um, like the parameters and some query uh, functions that are defined. This is more stuff that's under the hood that's being used throughout the workflow files here, right? And so that's just a high level overview of the source files. The other relevant directory would be the test directory. And here we're utilizing flu tip, which allows us to basically, inside the context of a test, we can spin up a local Cardano, cluster and execute some real world scenarios on there. So those actual tests, they're defined inside the workflow directory here. So each one of these. And I think that's pretty much it in terms of the most relevant files here. Pretty much everything else that you see is, defining some dependencies, makefile with some, scripts that could be run there, which is talked about a little bit further in the README here. So if we actually want to run the tests that I just mentioned, you know, we could do so just by running npm run test. And so you'll see in a moment the actual output as it's running through everything. So just expand that a bit. It's very noisy. We won't look at the specific details, but what's happening here is it's running through everything on the local testnet that was just spun up for testing purposes. But once this is all done, we should see the final test result in just a moment here. Okay, so we've got the green check mark. That's what we're looking for, just showing that the full workflow, you know, multiple proposals, votes, canceling a vote, etc. Um, all of that was executed in the test suite. The next thing here in the README is just building the code base here. So if we want to, um, if we've made some changes and we want to build the actual output, we just run spago build. Um, in this case, I've already built recently, so it completed pretty much immediately here. But essentially, the output directory here. That's where the build artifacts go, and that is, like I said, just basically pure, JavaScript. Um, and then so what we can do next is actually just pull this into another code base, so a front end. Um, and in order to do that, if you're developing this locally and making changes, and you want to see those reflected, immediately, npm does have, a nice helper function here, which is npm link. So if we exit the Nix shell and we just run in this directory npm link, it's created on my system an npm package that we can just import directly into another code base. Right, so I'll just copy this command here from the README. And so at this point, if we actually want to utilize this library outside of the testing suite, then we'll have to pull it in to an actual, JavaScript or TypeScript code base. So I switched over to the actual TripHut front end repository. And so if I run that command npm link TripHut DAO offchain, it's essentially just copied that over into the node modules directory, and then we can utilize it here as if we had just run it from npm install. And so I've already got everything, wired up here. So I'll just give you a quick overview on how we're actually utilizing it in this code base. Um, so you'll see at the top here, it's imported as, TripHut DAO offchain. And here, this is just a wrapper, essentially, just to make it a little bit easier to call these functions from within this front-end code base. But you'll see here where we're actually using the off-chain, creating the configuration, deploying scripts on chain. There's a lot of functionality here, but like creating proposals, all of that here is defined in this file, and then it's pulled into some various React components. It's actually there's another layer of abstraction here, which is some hooks that just take care of all the React query, all of the fancy caching and that sort of thing, right? But to actually show you this in action, I'll go ahead and actually start up the front end here. So in order to do so, I'm just going to run yarn dev, and you'll see here it's created or started up a container that has the database. And so we just store a little bit of additional information about proposals when people submit them in the application, which I'll show you in a moment. It's just saving some additional information that doesn't need to be stored on chain in that database. But otherwise, everything else will be interacting with the blockchain. So I can go open this up in the browser. Okay, and so we'll see the actual TripHut front end here. Uh, the first thing that we can do is go ahead and connect the wallet. And this is just set up just to use Nami right now. It'll be expanded to support all of the other popular wallets, but for the time being, it just connects directly to Nami. So go ahead and grant access. And we'll see here that I can see my Nami address. We are connected. And for the very first time when we launch this application as like an admin user, there's a hidden admin page that I'm going to navigate to. Okay. And I'll go ahead and just open up the console here, clear that out. Okay. So what you're seeing here is just a UI for an administrator if they're doing the initial setup. So what needs to happen here is first thing is on the blockchain, we need to initialize the smart contracts. So there's an index that gets created on chain, which is just utilized to basically increment a number every time there's somebody submits a proposal. It gets a unique ID based on that index, and then there's an actual configuration datum on chain that contains all of the configuration for the DAO itself. Now, all of that is defined in the off-chain library that I was showing earlier. So in this case, it's just going to deploy based on the configuration that was set there. And so I'll go ahead and do that. Just click on this button. You'll see here over in the terminal, this is just some verbose logging as it's building the transaction. And then we'll see here the Nami wallet requesting to sign that transaction. So go ahead and do that. Okay, so that would have been the very first creating the index. At this point, it's just waiting to get confirmation that that transaction exists on the blockchain before it proceeds with the next step. Okay, so it's now building the transaction. So this is the transaction to create the configuration on chain. So I'll go ahead and sign that. Okay. So now the process is complete. We'll see in the terminal here the result. I'm just going to go ahead and just copy this entire object here. So we're going to switch back to the front end code base here. Um, I have a .env file here that I've created based on the example that's in the repo. I've just cleared out the fields here because I'm going to be populating them in a moment. So pasted it in what I copied from the console in the browser, and basically has the key information that we need, or at least most of it, for up here. Right. So one of the things is the index symbol for here. So that's just the unique identifier on chain to be able to find the UTXO with that index, and we'll do the same thing with the token name. Now the configuration, same thing. It has a currency symbol for identifying it on chain. In this case, we've just got an empty token name, so I'm going to leave that blank here. And then the tally symbol, and this is basically for the proposals or requests that people are submitting um, on chain. There's a tally datum, and it stores basically information such as the votes for and against the proposal. So that's just the identifier for that. Okay. So I've gone ahead and I've saved those changes. We don't have the treasury just yet, so I'm leaving that blank. So we'll switch back to the browser here. And so those changes should be reflected. Just for good measure, I'm just going to go ahead and refresh the page. Okay. So the next step is there's some scripts that we're going to need to actually deploy on chain. And so this is going to be 3 sets of transactions, fairly pricey transactions. Thankfully, this is testnet. And so the reason we're doing this is essentially so that every time we submit transactions for creating proposals, voting on them, counting the number of votes, all of that, we don't need to attach transactions directly to the, or I should say, scripts directly to the transactions. We can just reference them from the blockchain, and it keeps the transaction sizes down that way. Okay, so that's 2 of 3. Okay, so this is the final transaction, at least for deploying these scripts. Okay, there's confirmation that they were deployed successfully. So at this point, we've deployed the initial configuration, the reference scripts. We're going to go ahead next and just create the actual treasury for the DAO. Now this is just for testing purposes. It's set to 500 ADA, but that is configured actually in the front end. There's just one line that controls that. Okay, so we see 500 and change coming out of my wallet for the treasury. I'll go ahead. Oops. I'll go ahead and sign that. All right, and now that we've created the treasury, the next step would be just getting an actual pass here, which will allow us to vote. Um, Now this is just for testing purposes right now. When this is on mainnet, uh, users aren't going to be just creating these vote passes for themselves. Um, but for testing purposes, it's handy to have this here. So I'm going to go ahead and sign that. It's going to send one of these to my wallet, and that will allow me to actually vote on proposals. Okay, so that's happened successfully. So at this point, we've completed all of the configuration, and we're essentially ready to actually take a look at how we would use this, as an end user, which we'll do that in a separate video. Thank you.